Well, this video is a follow-up of my video I had on my back rolling table or my intervertebral traction table. I've had some requests for some additional information, so this is what this video is all about. I've gone ahead and uploaded the Arduino code to GitHub under the JTOTAT channel, so to speak, and it's under the repository back table. You can just download the code there. And again, there's no guarantees here. I'm doing the best I can to make sure everything is accurate. No liabilities implied. You're on your own building this thing, and if you screw it up, well, you'll learn by it. But it's actually, and go in here kind of with your eyes open. This is a big project. For me to build this, I had to be able to weld, for my version anyway, weld aluminum and weld steel and woodworking projects, some skills, wiring and coding. So putting them and then put them all together with powertrain and have it work. And I think it's well worth it. I've really enjoyed the outcome, what I got here, and other people have enjoyed it as well. But I can see why these things cost thousands of dollars, because there is a lot of work into building these things. But if you want to go this route, that's what this video is all about. So first off, build a box. Now it looks like it's not very square, but that's just a camera perspective. It's 72 inches long, 24 inches high, and I used 5-ply plywood. Pretty good grade of plywood here too. I used 2 a lot. Sorry about that. I'm working on it. So I really recommend the locking swivels, because I found out when people get up in this thing, including myself, you're dizzy. It's like universally, everyone has used this, and then they first get up like, wow, I'm dizzy. And if I would put locking swivels on this, that way if they have to use the table to brace themselves, it's not going to roll away. You can see some additional framing of this 2x4 frames I used here, because a lot of the, there's a lot of stress inside this plywood box. There's another box inside that rolls back and forth, and lots of weights, and I'm on top of it and everything. So I thought, instead of just having the plywood taking all that stress, go ahead and put some additional bracing underneath that, and it's been working fantastic. It's 22 inches wide. Now the top you see here is not securely fastened onto it. It just sits into a little recessed area. I did mount an exterior switch. This is nothing more than a cutoff switch to the battery. When you flip it on, it energizes the Arduino. It homes itself and starts the whole routine. And the way this thing does it, I talked about that in my video. It does half the back one direction, and then it reverses the motor direction for the wheels, and so it helps to decompress both areas. It's been working good. The top I just recessed with 2x4s and some 1x's here, and that's what the top fits into. And there's Chester. I didn't even realize he's in this picture until I saw this, looking at it later. And the braces don't even go around the perimeter. I did not need them all the way around, and the plywood itself has enough strength to gap that. It is 10 and 1/2 inches tall and 14 and 1/2 inches wide. This is this interior box that it's pushed and pulled along, and this is the box that holds all the gears, all the motor and all the electronics. It's very strong. There's a 2x6 here in the back. The other, it's 22 inches long. Here's the 2x6 I was just talking about. It's also made of the 5-ply plywood. I put in some additional shims for these extra casters. I'll talk about that, why they're there. There's the backside. It's actually a 2x8 I used in the backside, and this thing's all lagged together and very strong. I did cut a notch on the bottom 2x8. That's just for the other the 24-inch linear actuator that actually pushes and pulls this whole mechanism back and forth. This is why those little side wings are on this interior box. They hold the casters in place, and now the casters, whatever size you use, is really that's adjustable as long as you have clearance. This thing cannot be dragging on the bottom, whether you're on the plywood or on these frames here. It's got to be above that. I think these casters I'm using for mine, and these are straight non-swivel casters, I think they're 2 3/4. For perspective, this top one here, this top caster is a 2-inch wheel. I couldn't easily measure these when it's already built, but it doesn't really make that much of a difference, because if it's higher or lower, you'll just have to adjust where you put this 2.5-inch, for my size, 2.5-inch cut down 2x4. As long as it clears in the bottom. Now, the reason these top casters are on here with this little shim to get them in the right position, because there's no tracking mechanism. This thing just pushes back and forth. So these casters, and I had 2 fixed and 2 swivel, and if I would have had all fixed, I would have used that, but this is what I had on hand. Their job is to keep this tracking correctly. So if it gets close to one side, the caster takes over and pushes it back, and I'm sure these are working. I never hear them. I've never had a problem, so if it's not broken, I'm not going to fix it. You can see in the picture here, I did add a little bit extra bracing on this 2.5-inch piece here, because there's a lot of stress on this. I'm on it, the motor's on it, everything's on it, so yeah, I want to make this pretty strong. Okay, I use these 2x4 bottom rails, and again, I made this a little bit bigger than I had to, because this is the first and only one I've ever built of these things, and I wanted to make sure I had plenty of space. However, when this is just dragging on the bottom on the plywood, the revolving wheels were pretty far below, an inch and a half below the plywood. And I thought it was just a lot of extra time, but you had to activate the wheels to raise it up above the plywood. So actually lifting it up 1.5 inches on these 2x4s, an inch and a half thick, took the roller right to the top of the plywood where it should be. So when the roller top is all the way down, the wheels are just the height of the plywood. And that's nice because you hardly even feel it, but then you can control it up and down with your little remote. So now on top of that box I built this framework of iron or steel here, and it's 14 1/4 inch by 21 inches long. However, it's got some extensions. On this side, you can see back here, it's extended out a little bit because I have to have that pillow block bolted to something. And I also put this extension on the other side with the motor, and that's actually not the top though. That's another piece of angle iron I welded on upside down. I'll explain why I put that on there to help hold the motor here too. So this whole thing is actually one piece, and it actually pivots on the back here. In fact, this is what I'm using. I didn't even have a pair of hinges, but I had these 2 strong hinges. I just used what I had, and I drilled a hole where I needed to, and bolted the hinges on, screwed them to the 2x8, and it's very strong, had no problem with it. Now this is the 2 inches. I recommend you extend the rails at least 2 inches on this one side. That'll give you space to put the bolt for the pillow block on that side, and the pillow bearing on that side. And the other side, I welded the 6-inch long extension. The reason for that is, when this thing raises up, the motor hanging under it is going to get closer to the electronics. So you've got to get this far enough back so you're not going to have any conflicts of this thing hitting any of the electronics back there. And this it will not get up that high to get that close. So this works fine for me, 6 inches here. Now again, I just used this 1.5 inch by 1.5 inch by 1/8 inch angle iron, same thing I made the frame out of here. And I welded another section here of 1 1/4 by 2 inches just on top. And it doesn't quite look like it on the picture here, but this is all one plane. These pillow block bearings like to be bolted on one surface, one smooth surface. So I welded up and ground it down, and it works just fine. Now, to mount this motor, this is the 12-volt, 50 RPM motor, maker motor. You can just look that up, and they still sell these things. To mount this, I took that same 1.5 inch angle iron, and what I did, I welded another 2-inch piece on that. So the angle iron now is 1.5 inch by 3.5 inches, and that's this piece that you have a hard time seeing here, but I bolted that in underneath of that additional piece of angle iron. I put it upside down. This is why it would mate correctly. And I also have the 24 tooth sprocket, and all my sprockets and chains are size 35. It's just made it convenient that way. So, and this piece that holds the motor is also 4 inches long. Here's another picture of it from the top. There's the 4-inch length I have where I bolted it to. And there's 4 holes drilled in that. A big hole right in the middle, that's the D shaft coming from the motor. Then there's 3 additional corresponding holes that made up to the holes that mount the motor on here. So I've not really had a problem with that. And again, I drill my holes a little bit oversized. It gives me a little room to fudge around and push them back and forth. And the pillow blocks are nice because they have a elongated hole, so you can still have a little bit of adjustment where they go to and make sure you're chained. But I would recommend getting some chain couplers and even some chain and a half couplers, so you can actually get increments of how much spacing you need to increase your chain if necessary. Okay, from that 24 tooth sprocket, this is how I reduced that motor. I reduced the speed and increased the torque because by itself it's just not strong enough. However, with this configuration it is uber strong. So that 24 tooth sprocket goes up to a 60 tooth sprocket. Of course, that transfers the power across to this 12 tooth sprocket up to another 60 tooth sprocket. So I've really reduced my speed but increased my torque here. Now everything here, all the shafts, everything's 1/2 inch. All the pillow blocks are 1/2 inch, the stops are 1/2 inch, everything's 1/2 inch. Now you can't see it very well, but these are keyed shafts too, because this sprocket hub here has a key in it. Now it does have a little slop to it, and I'll explain that's probably not a bad thing, but this is how I reduced it down. This is that key hub I was just talking about. It's actually, there's no set screw in it. And originally I was thinking, well, because it has a little slop, and when you get on your back, it raises up, and then it starts going downhill, so to speak, it'll jump just a little bit. And it may be one of these lucky happenstances because it gives you just a little bit of a jarringness, and that's sort of not a bad thing sometimes. I think the chiropractors use that type of phenomenon. I don't know, but it may wear this piece longer. If it does, I'll replace it, but it's going to take a long time before it probably wears this one down. But I like these hubs because you can mount them to any of these style of sprockets. In fact, I use this same type of hub to mount my aluminum wheel holder. And this aluminum wheel holder may be a sticking point if you're designing this and can't weld aluminum. It's the only piece I really used of aluminum to weld up, but I'm pretty certain you probably could make this out of that Baltic birch plywood. You know, the stuff that's got uber layers, almost like veneer type of construction. If you had a couple pieces of 1/2 inch or 3 pieces of 1/4 inch glued up with that Baltic birch plywood, I think that would be plenty strong. That stuff is very strong. But for me, I can weld up aluminum, and it's easy to machine, and that's why I use aluminum. And you can see how this was easily put together. I had this 2 inch by 1/4 inch piece of aluminum bar, which I just have the straight bar here. But then I cut this. I think it was 60 degrees a cut, because that'd be a 120 or 180 for length. And but once I got it all welded up, ground down flat, I just put my compass around it, and the holes are 4 1/4 inch center to center, equally distanced, spaced around. And once I got this first one made, I use it as a template for the back one, because that's what holds all these wheels on here. It's been working fantastic. Again, I have to have some stops here because, again, there's no set screw in this particular hub, as I talked about. It just kind of keeps it centered. And also, I would recommend the linear actuator I used. I got these out of a wheelchair I was tearing apart for parts, and these have about a 12 or 13 inch total distance. Okay, these are very strong. I don't know how many pounds are put out, but you know, there is an equivalent on this for Gelly. I think that's how it's pronounced, on linear motors. They have a whole series or two that these things would also work. If you get a 12 inch, it would be perfectly fine. However, I'm only probably using 4 5 inches to travel total when this thing lifts up, because it only raises the wheels up maximum about 4 inches approximately above the plywood, which is really too high. It's very uncomfortable. I don't think you really want to run it that high. In fact, I found out if I decrease the height so it's not so vigorous on me, it's just running up and down my back, it's put me to sleep several times, which is kind of bizarre, but it's a very comforting thing. But my point is here is that if you mount these bearings first, you might hit that linear actuator. So I would really recommend you put the linear actuator on first and make sure you get clearance, because this thing is pretty tight tolerances, and when these wheels rotate, they get pretty close to this linear actuator here. They don't hit it, they can't hit it, and it gets better as it raises up, and when it's all the way down, that's about the closest it's going to be. So put that on first, then you'll know exactly where to put your bearing blocks, and so make sure the wheels will mix. I miss it then too. Now I use pneumatic wheels, however I'm running them flat. There's no pressure in these things. I could not find the right wheel that actually had the right amount of cushiness and also firm, and I figured this is a good compromise. So I'm running these 6-inch wheels flat. However, you can see here I'm actually using some 2 inches of foam. I had this piece left over, and that really makes it much more comfortable. These wheels do a nice job. They're firm enough, but I don't think I want these things. They're almost too firm to run directly on your back. That's why this foam works really well. I got these from Zorro, and they're listed in the part list in the back of this video. This is how I mounted them. Mounted the linear actuator. I just cut some more pieces of angle iron, same angle iron, drilled some holes through it, walled them in place. This had to be pretty strong since it lifts me and everything up with it. I did the same on the other end. Here you can see the outside of it. A little closer here, wrong direction. There we go. This is the one I mounted underneath the wheels, and again, I thought this needed a little bit more strength than just bolting to the plywood. So I welded up another piece here, and same type of construction, angle iron in here, dual holes across, and I put this very long bolt in because that's just what I have at that size. But yeah, I thought this needed a little bit extra strength to hold it together. Here's a back picture of it. And here's the other linear actuator. This is the 24-inch one. This is the one that actually pulls the whole box back and forth. It does not need to be near as strong because, well, first off, it's not lifting up me, and I'm about 6'4", 230 or so, and this covers my whole back area. I like the distance of it. But again, this doesn't have to be that strong. I did just manage to attach it to the plywood in the box, and then on the other end, I attached that 2x4 to the box, lagged it from the outside and bottom, and then put this little pin in the bottom here too. Now, you can see I'm just running a battery. This runs on a battery, 12 volt here. I do have to charge it up once a month or so, and depending how much I use it. But that made it real simple to use. Nothing plugged in, no cords, and all independent then. So I really recommend that. Now, I did add some homing and some limit switches. When you first power this thing on, what it does, it actually will take the whole box and drag it all the way to the head of the box, and then the software starts and the wheels start turning around. So this is nothing more than a normally open switch, which I mounted into a piece of aluminum and just screwed on the end, and so that hits the wall when it gets all the way up there. Now, I do have another limit switch. This is the down limit switch of the whole top mechanism. When it comes down, it'll trigger that switch, saying it's all the way down and don't go further because it's all the way down, tells the software. I do not have limit switches on the other end or how high it'll go. In fact, this thing will go so high, it'll actually lift you and the plywood up. That's something I found out. So you'll know it when it's too high. And I count the number of repetitions. It does a bunch of it starts, you hear the linear actuator move a little bit and then a little bit as the wheels roll, and it counts how many revolutions that moves. I think I'm around 70 or so. It will actually, it'll say I'm at 70 and then reset itself. And the software is not elegant because you cannot, the remote, you just can't push it any time because it's actually not an interrupt. When the linear actuator motor, the length one, when you hear that moving, then it's active. You can push the button on that and hold the button. You'll see that in the software. If you just try to push it, it may not be looking at that pin at that right time. Like I said, it's pretty crude software, but if you know how to run it, it's been working fantastic. So I do use an Arduino Uno for this, which I had this shield, custom shield made. This is not even made for this project. This is one I just had left over from another project, but things are so similar. However, you don't have to get into making printed circuit boards to do this. I found this. This is a proto shield from Adafruit, and it would be just perfectly fine. This will give you pins necessary to solder your pins on for your 3 pins for your Rev Spark controllers. It would be screw terminals to make it nice and easy. SparkFun also has a version, although theirs is all solder instead of the screw terminals. But if I did not have a custom shield already made, I probably would have used this. So I like these Rev Spark motor controllers. I had these big ones on hand. These things will theoretically do like 60 amps, so I'm really underutilizing these things. I probably could have got by using the minis for all these, but I do like the screw terminals. It makes it real easy to connect things. I really would recommend, if you're going to build this particular device, get these ordered, start playing with them, the code. They work great. The only problems I've ever had with these things is if you have an LCD monitor. Sometimes the LCD interrupts will interfere with these servo controllers, and you'll get a little jerking and movement sometimes, that you do not expect. But there is software workarounds for that too. But I'm not using any LCD in this project, so it was not a problem. I do not use the LM05 or LM08 linear voltage regulators anymore. They're just too inefficient, and when I get close to using their capacity, they start heating up and they start giving me all sorts of various voltage. And if you're ever using any analog inputs, it will really screw up that signal because your reference voltage is moving around. So I've been using these little DC-DC 5 amp buck converters. I get these from Amazon, a 2-pack, and I really like these things. And you can see right now I'm only running 7.1 volts because my battery is needing charging. I usually run these things around, I think, 8.5 volts, something like that. And the reason this is necessary, because this lead acid battery that I'm using, when you charge that thing up, you may get 13, 14 volts out of that thing, and that's going to be more than the Arduino is really going to like. So it's nice to kind of regulate that voltage coming into that, into a safe level. There are 2 switches on this thing. If I push this switch, it would show me the input voltage. However, I have this one active on the out, and that just shows me the output voltage going right to the Arduino. These are the 3 pins I was talking about that hooks up all your Rev Sparks. And again, even if you had the Proto Shield, you could just solder 3 pins, because all this is your output voltage, output signal I should say, your voltage, and then your ground, the 3 pins or 3 wires going to your Spark Rev controller. Of course, the other end has to do with the voltage and power, and then the motor contacts. And all these pieces, I just went ahead and screwed them to this 2x8, made it real simple. It kind of got, it's kind of like a rat's nest of wires, but most of the stuff is just, routing the ground and routing the voltage to different places. And I did try to contain these wires so nothing is dragging, which is helpful. What you also see in this picture here, this is a little piezo buzzer I just mounted, a 3D printed little holder here. And when you push the remote, it will give you different lengths of tone, meaning it received the signal for this or for that then too. And I do use a lot of these little bus connectors to help distribute the voltage around. There's another big batch of them over here, because you need a lot of grounds and you need a lot of voltages to hook up here to everything. So let's see here. Now, this is the remotes I use. Now I had a printed circuit board already designed for this, and I'm using this one, but you probably could just do this on the prototype board, because it's kind of simple. There's only 2 wires here going to voltage and ground, and these 4 output wires, and these things are high, which means there's 5 volts on each line. when a corresponding button is pushed. This other blue and orange one here, that's just the antenna. I route that out of the way. Now, the only information I had about this on the board, on the back of the board, it says SR-YK04. I bought these a long time ago. They may be rolling code, but that doesn't really make a difference on this particular one. But this really makes this machine come alive, because you can sit there and I can stop it at one spot if I want to work. I can raise it up and down, or just reset the whole thing. So I really like this controller to make this a little bit of a smarter machine. Okay, like I said, more of a rat's nest here, but and again, that's nice to have these on board. This is my remote down here. It's nice to have everything attached, because if I had switches on the side, well, then the wires are getting pushed and pulled and stretched and bent, and I like everything contained on the back. Even though it's kind of a mess. Here's my other buses I was talking about over here. It's been working just fine. Here's my schematic, simplified as it is. Now, you are going to need a couple pull down resistors. Now, what a pull down resistor does, if you just have a pin, hooked to a switch, well, that pin may be getting some stray voltage, and there's a lot of stuff fluctuating around, and it may trigger when you don't want it to trigger. What a pull down does with the 10K resistor here, it pulls that pin down to ground, but then when you do hit the switch, it puts so much 5-volt current or voltage through that overcomes that resistor, and you get a definite signal that you've actually had a button push. And you'll need two of those. Two resistors for the pull down switches on both the home button as well as the top down button. I did not have to use them for the inputs or the outputs from the remote control, because they seemed like they had their own pull down built into them. Never had a problem with that. Here's a piezoelectric down here, plus side to the pin, of course, and then ground to the black side. There's your power coming right from the power supply board and the common ground. All grounds are common. You can hook them all together here. So, and again, a lot of these numbers you can just look at the code, and you'll say, oh yeah, this is exactly what you need here, because it'll say that pin goes here, and that's exactly what you're seeing right here. Here is my part list for all the parts. Prices, I have no idea. Things have changed too much in this crazy world, but some are about the same. For Gellies, about $130 for the 24 inches, I think, and that's about the same price if you're getting the same company for the shorter one as well too. And again, I try to do as good as I possibly can with everything here. But if I did make a mistake, if I missed anything, my apologies. I still use the word too much. Too bad. I'm trying. So anyway, I hope this helps.